Ed received his bachelor's degree in chemical engineering from Yale University in 1961, and a master's and a PhD degree from the University of Wisconsin-Madison in 1965 under the direction of Ed Whitefoot. After his PhD, he was a postdoctoral fellow in physical chemistry at the University of Adelaide in South Australia and at Yale. In 1967, he was hired by Carnegie Mellon University, and in 1980, he joined Minnesota. His research on separation processes led to election to the National Academy of Engineering and honorary degrees from Lund and Nancy. He served as president of the AICHE in 1995.
That my father was a chemical engineer. But probably what was more true was that I was interested in chemistry. I went to Yale as a chemistry major. But in chemistry, you had a lot of labs, and they conflicted with rowing. And frankly, rowing was the most important thing to me. And so I chose chemical engineering because the labs didn't conflict with rowing. One of the assumptions students make, undergraduate students, that's a big mistake, is that if you make a plot of what they know versus their score on an exam, okay? Students think that this is going to look like this. That if they know nothing, they'll get a 0 on the exam. And that isn't true. The first thing is there's a finite intercept. Because even if you don't know anything at all about the subject, if you even just write down your name without misspelling it or something, the TAs are going to give you a few points. And then for a while, you'll learn, you'll actually gain a fair bit. But the difficulty is that if you keep working and don't really understand the subject, there's a maximum. And so the trouble is, students get right to this point and they think, I've almost got this. If I work a little harder, I'll do better. And of course, that doesn't happen. They get down here. And then the trouble is they can't go back. They can't unlearn to get back to that point. And it is true that this goes up eventually. But it's going to take that much more effort. Students don't understand that. So you have to say that after every exam because they never believe it. You just have to keep saying it again and again. And eventually they do. Well, I think you start with triage. You remember triage was the attitude in the First World War, especially by the French medics. And they divided the population into thirds, the wounded into thirds. And you looked at the ones that were going to die anyway, and you gave them a shot of morphine. And you look at the ones that who could walk, and you told them to just walk back behind the lines. But it was the ones in between that you spent your time with. And that's how I chose students to spend time with. In other words, you want to take the low C students and convert them into high B students. The A students will take care of themselves. And the students are going to fail, you probably can't help anyway. So you focus on that group of students. Then within that structure, you want to give them as much structure in the lecture as you possibly can. You want to have an outline at the start of the class. Bob Bird did this very effectively at Wisconsin. And then, and I tended to forget to do this, you want to refer to the outline as you go through the lecture. The other thing is our students don't believe things. You were saying intuitive thinking. Here's an example. Most of our students believe they're above average in the class. And that clearly isn't true. Yeah. I mean, think about what an average is. That's an average. An average is half or above, half or... Okay, so you've got to constantly tell them about what average means. And you've got to point out to them that how hard they work is not necessarily going to translate into how much they know. As for why I like the history things, as you know, I have worked and lived in England twice. And the first time, on the last day I was there, I went to Westminster Abbey to see the tomb of Newton. And I hope you go and see it. It's an absolutely ugly tomb. It looks like a marble wedding cake. And Newton is kind of lying back with his hands open, and he's receiving from the deity huge amounts of information, calculus flowing through his fingertips, really stupid. And so I was thinking that. And then I look down, and if you look at the tomb of Newton, under your feet are the graves of Faraday and Maxwell and Kelvin, and Stokes is around the corner. And I burst into tears, much to the dismay of the group of older women from somewhere in Iowa who were visiting at the same time. Those were my people. And I'd been told all my life that I should get excited over poets' grades. Forget poets. These are the people who matter to me. And I think you want to think about that. You want to think who came first, Gibbs or Newton. You want to think, what were they like? I mean, that's our culture. And to have that culture be part of learning more formal chemical engineering, that's important. This is an absolutely astonishing place. Universities, especially state universities, I think, have this incredibly idealistic assumption that education of this huge number is even possible. But then there are other sorts of things that you can think of. The English writer John Donne actually wrote, "The university is paradise. Rivers of knowledge flow from thence." And that, I think, is true. It's just wonderful that you can participate in that type of institution, in that enormous effort by a huge number of bright young people to potentially change their position in life. That's a sacred trust. That's wonderful.